Hi, in this video I'm looking at this problem here where we've got the mean sample of 60 items was 82 and it had a standard deviation of 12. And we want to determine the 95% confidence interval for the population mean mu. So when we have a sample, our population mean mu is the same as our sample mean x bar. So in this case, it's 82. And we want to determine the confidence interval. But that means that we need to get the population standard deviation from our sample, which is given to us by the sample standard deviation divided by the square root of the sample size. So we've got a sample standard deviation of 12 divided by our sample size of 60. So if we work this out, our population standard deviation based off of our sample standard deviation is going to be approximately 1.549. So we're going to put in 1.549. So now we need to get our confidence interval. Now our confidence interval is given to us by our population mean minus the quantile for our confidence interval times by our population standard deviation, and the mean plus the quantile times the standard deviation. Now there's two ways of getting this information. We can find the quantile for a standard normal deviation, and we can do that from memory. And from memory, the Z, the quantile for a 95% confidence interval, if we get we'll get the upper bound, is 1.960. And we can get this another way by getting a graphics calculator out and going to our run matrix if you're on a Casio, option, stat, distribution, normal, inverse distribution. But first, before we can use the graphics calculator, we have to work out the proportion required to put into here. And that requires us to work out the proportion alpha, which is going to be 0.5 plus or minus our confidence interval as a decimal divided by 2. So we're going to have 0.5 plus 0.95 over 2. So our alpha, I'll put it in here, is going to be 0.5, we'll do the high end again, plus 0.95 divided 2, which is 0.975. And so when we go to our calculator and do our inverse normal, we can put in our 0.975. Standard normal has a standard deviation of 1 and a mean of 0. And we get our 1.960 that we got here. So once we got our Z, we just have to do this calculation here. So we can get our confidence interval by doing our mean 82 minus our Z, which we got from memory, or just worked out in the calculator, 1.960, multiplied by our population standard deviation we worked out of 1.549. And we also do the plus version of that. We can have 82 plus 1.960 multiplied by 1.549. And so if we go and put these into our calculator, I'll use this one. So we've got 82 minus our 1.96 multiplied by, and I'll just use the answer that we got for our population standard deviation. And so we get a lower bound of 78.96, so we can have 78.96, and we can get the upper bound by changing our minus to a plus. Except for the fact that I was using answer, so I can't do that because my answer changed. So I'll go and rework out our Z, and we get our upper bound of 85.04. So we get an upper bound of 85.04. This is only an approximation, so we'll get our confidence interval to 3 significant figures. So we'll have 79.0 and 85.0. If we want to continue using our graphics calculator as an alternative method, we can go and get our alpha like we did up here, but instead of putting in the standard normal, we can put in the information that we have. So we can put in our 0.975, and we can put in our population standard deviation that we worked out here. I'll put that in as its calculation so that we actually have the correct number. So because I don't have the calculation done, I can't use answer. And our mean of 82. And because we use the upper proportion, we'll get our upper bound of 85.04. And so we have our upper bound to be 85.04. And so I've got my mean of 82, and then I've got my upper bound of 85.04. And I want to know what my lower bound is. So my lower bound is going to be our mean of 82 minus off whatever this gap here was. And that gap's going to be our upper bound minus our mean. And so putting that into our calculator, we can have our 82, our mean, minus our upper bound, which is our answer, minus our mean. And we get 78.96. So that gives us our lower bound of 78.96. And so we can have our confidence interval of 79.0 to 85.0. And there we go. So there's two ways of getting our confidence interval if we have our sample. You always need to start off with the same calculations. We always need the population mean and standard deviation. Population mean is the same as the sample mean, approximately, and the population standard deviation is given by the sample standard deviation divided by the square root of the sample size. And so then we can put in our confidence interval rule, either using Z from our alpha and using the standard normal, or from memory and working it out using this rule here, or we can put it into our calculator and get our answer.